Hello. Today in this class we are going to cover introduction to big data and introduction to Hadoop. So let's start with the introduction to big data. So what exactly big data means? Big data, as name suggests, is big. Big thing is big volume. So nowadays there are a lot of social networking like Facebook, Google Plus, Twitter, LinkedIn, which is every day generating huge volume of data. Facebook alone each day generates 10 terabytes of data. Twitter generates 7 terabytes of data each day. So this with the data is being generated every day is in volume is very huge. So in volume how much exactly? So like we'll say previously the data was maximum is considered in gigabytes, but nowadays data is generated in terabytes to petabytes, and sometime in future it will reach to zettabytes. So this is a huge volume of data. Other industry, this is social networking industry. If we consider other industry like finance, where the data makes a very big difference, is like stock market, which has globally hundreds of stock exchanges. There are other data like companies fundamental data. So this is also generating in volume, we'll say per day gigabytes or terabytes of data, and collectively a full history we consider, so it reaches in terabytes, petabytes, and even most of the company has started using the big data framework to handle this volume of data. So this is the actually represent the volume of data in big data. And other than big volume, if we consider, there is another characteristics with the big data, which is variety. What variety means? Variety here, the data is generated is structured, semi-structured, or unstructured data. So structured data is your normal SQL format data, you can say CSV file, comma separated file, or your pipe separated file, which has first field, second field, third field. So this is the structured data. Semi-structured data means you can consider like blogs. You would have email, etc. This is semi-structured data. What unstructured data? Your audio file, your video file, your images, these are all unstructured data. So if you see in healthcare industry, lot of images are being generated, like patient data is there. Even you upload the images on social networking site, you upload videos on social networking site. So this is all unstructured data. So processing this unstructured data is also difficult, and structured data, semi-structured data. So this represent variety of big data. There's third characteristics of big data, that is, we'll say velocity. Velocity, as name suggests, well, how fast is data is generated. So as you know, there are every moment you have Facebook is getting huge data. At the same time, every day stock market opens, so huge volume of data is generated. Every day medical industry is generating huge data in every moment, or in every millisecond or nanosecond. Or other industry, if we thought or not, telecom industry, your mobile devices, your GPS system, your other security infrastructure on the computer network. So these are all way the data is generated in the the speed it is generated is very huge. So overall, if we summarize, so big data has three characteristics. So if we summarize big data, first is volume. This is petabyte or up to zettabytes. Variety, as we have discussed, structured, semi-structured data and unstructured data. Third is velocity, how fast data is generated. If overall we consider nowadays, the challenge here is the data is increasing this way. If I will draw a graph, so data increasing this way day by day, and the percentage of data is being processed is going this way. So overall this gap is increasing. So because of this gap increasing, we are losing a lot of valuable information which is in big data. What valuable information? If you consider stock market data, it has huge data volume, but throughout history, like 30-year history data, if you have to process it and generate some risk model, so it takes months to process this whole history to run and generating some analytics over there because of existing legacy system. So similarly on various data, social networking data, medical data, these all are having this problem. So to solve this problem and processing this huge volume of data, a new framework is introduced, Hadoop. This framework has evolved day by day. Okay, it's not created in one shot kind of thing or predefined design kind of thing. Okay, so let's start with our traditional approach, how we were processing the previously the data, or nowadays still we are having some traditional approach or legacy approach to process this data. To make it simplify, if nobody knows how to data is processed in normal way, so there are systems which are generating data. This is CRM data or some your ERP data, one system, or we can say stock market feed we are getting, or your patient data. So as soon as data reaches in your system from outside, you have to process it. So you will put some ETL processing over this. So what this ETL framework does, it extracts your data, transform it, and properly normalize this data and store into the RDBMS system. So in proper tabular format, you have this data. And now your another world, which is downstream system, if you can say, which wanted to analyze this data and generate some report, analyzing this data and generating the report out of this, or something we'll say what I'll say in finance industry, risk modeling has to be done, or some trading has to be done, and this data needs to be analyzed. So the volume of data resides in this RDBMS format. It's quite possible, like data volume is in gigabytes, so you can easily process it. Not easily, it will take like 6 hours or something, or a day something, or 2 days something maximum. You can process it and generate this report and produce it. But this data, suppose, is become now this data becomes, let me clean it out first. Now suppose your data becomes big data, which is possible nowadays, gigabytes to petabytes. Let's be reasonable. So processing and storing in normal RDBMS system is very difficult. Is difficult. Not even difficult. It is near to impossible. So there are various vendors which are also enhancing this RDBMS systems and trying to accommodate this data into their system, but still they are failing because this is the hardware limit. Okay, so there, as we have seen, there are a lot of challenges. So we'll say, let's summarize what are the challenges we are facing with the big data. In big data, first challenge is here storing. So how do you store this petabytes of data? Because your one machine hard drive limit is 100 gigabytes, and you need stores in thousands of millions of gigabytes. If I'll say MGB, millions of gigabytes, that's not possible. So you need a lot of machines to store this data. Let's discuss is how to store with using multiple machine in later session. Second challenge is processing this data. Suppose somehow we are able to store this data, petabytes of data, big data, let's say, but how to process in timely manner? So any competitor will generate report and it produce reports before us, so it is difficult to survive in the industry. So we need some timely solution which can run processes over this and produce report out of this. So this is another challenge. Third challenge here is variety of data. So your existing system might possible structured data can easily be processed. Your existing framework are able to process, but now we are coming with the semi-structured data and unstructured data. So over this we have to write some processes which can easily process this data. So this is third challenge. And the fourth problem over here is we are previously it is quite possible, like we are able to process not petabytes of data but thousands of gigs on some machines from big vendor, but this is very costly solution and every IT company or cannot afford such solution for long duration. So this is another challenge. So these are the four very generic challenges over the big data. So solve this problem, a new framework, as we told, Hadoop has been evolved. So let's see why Hadoop actually and what it provides actually. If we'll consider our big data challenges, so big Hadoop framework is first and very important thing is cost effective. Why cost effective? Because it works on your commodity hardware. Commodity hardware means the machine or the which is your in daily use can also be used to make the Hadoop cluster. So this can work on your cheaper hardware. It doesn't require very costly hardware. Okay, so now next challenge is solved by Hadoop is big cluster. So using your commodity hardware you can make 1000 nodes of big cluster. So if you have 1000 nodes in your cluster, so you can have bigger storage and more processing power. Okay, so now the second Now, third benefit of is parallel processing. As we told, there are 1000 nodes, so you can using its MapReduce framework. We'll discuss about this MapReduce framework. Thousands of nodes can run your processing in parallel and generate the result in timely manner. So this massively parallel processing will help you to process your data, which was previously taking months to process. It can easily be processed in a single day or in less than 24 hours. And big storage, as we have discussed, there are 1000 nodes. Each node stores 100 gigabytes, so you can store 100 gigabytes multiplied by 1000 divided by your replication factor RF. We'll discuss about what is replication can be stored over here. So let's say replication factor is 4 here. If I will increase it, so 250 multiplied by 100 gigabytes, so you can store up to this much data over your 1000 machine, which was previously almost impossible to store such amount of data. The best thing which is every cluster required is failover mechanism. So Hadoop framework provides automatic failover management. If any node crashes, so your framework will identify that node crash. Your node, simply you assume it as a your computer or one machine over here. Okay, you can easily imagine. Okay, some little bit difference is there, but still that is okay. Sixth benefit is data distribution. How to distribute data over this thousands of nodes which are in the cluster. So it is Hadoop framework itself handled to distribute this data over your 1000 nodes, all your files. So this is another category. Next, if we'll say MapReduce framework, as I told, this framework specially designed and will work on Hadoop framework, which will help you to very generic framework which map and reduce. You have to write one map class and one reduce class to process your whole data, and some it's not that simple. You also require some supporting classes, but relatively simple. It's not that complex, but we'll see how actually the API wise is implemented, and we'll do some sample coding in next or later session. Okay, so let me clean it out and see one most important feature of Hadoop framework, that is eighth one. If I'll say moving code to data, what does it mean? This sentence means, so suppose your system previously, and this is your database RDBMS, or let's say S2 is in New York, okay, and your IT systems, or this is, let's say, let me clean it out, this is not proper. So this is your client of this data, these are all your client, and want to analyze the data stored in this. So to run some processing over this, they want, so whole data first needs to be bring over here on this machine. So like gigs of data, and let's assume these machines are in completely, client is in somewhere else in India, okay, and your data centers in New York. So moving this whole data over the network and bringing over here and processing it introduce big latency. But what Hadoop framework says, do this reverse. You have your cluster in New York, Hadoop cluster, there are a lot of machines in the cluster, and these are the client. So this cluster is capable of running some your MapReduce code. So client will write MapReduce code over here and sending this whole code over here, just megabytes or kilobytes of code. over the network and start processing over this thing. So this reduce your big latency which is done over the network transfer. So this has been reduced, and this is the another benefit of uh, moving code to data. So now next, let's finish it out. Next benefit is supports heterogeneous hardware, like you can mix up IBM machine, HP machines, Oracle machines, or Intel, whatever, or you can even configure different CPU configuration, memory configuration. You can make cluster of this different kind of machine in a single data center. Like this is your IBM machine, this is HP machine, this is Intel machine, or this is Oracle machine. So even though it's a different kind of hardware, but still you can make it with a cluster. This is, and the strength is scalable. You can easily introduce new node into this cluster without stopping this cluster. So this is normal J2E compliance features are available over here. So this is all about Hadoop framework benefits. So overall, how Hadoop cluster look like let's say this is your one data center, DC1, and another data center is DC2. This every data center has some rack. Okay, let's take here 2 rack only. This is 2 rack. Okay, and this has your 1 computer, 2 computer, 3rd, and 4. This is same way. 4 computer. This same way 1, 2, 3, 4. You have. So now, and this is by network, it is connected. So your Hadoop cluster has actually 16 machines in the cluster. Machines in the cluster which all are connected with each other. This all rack are connected, and your client which is near to data center 1 will connect with this data center and process it, and client which is near to data center 2 will connect to this data center and process the data. So this is Hadoop cluster kind of thing. So look-wise is not very different from existing your data center. It looks like similar, but the internal functionality and handling is something different. So this is Hadoop cluster. So let's say we have till now had understand the big data definitions and its characteristics and some basics of Hadoop, like what is the benefit of Hadoop. So if I would say, what is Hadoop? Hadoop is a Java framework for processing huge volume of data in a cluster. It has in core, what not in core exactly, it has, if we'll say Hadoop core technology. It is 2 parts. One is HDFS, Hadoop distributed file system, okay, and which is specially designed and based on Google file system. So, and the actual paper is published by Google, and after that someone Yahoo developer or architect has read this paper and designed HDFS file system in another some programming framework. That is your MapReduce. This is also published by Google paper over this, and by using that paper, the new API it designed. So it's completely, most of the things started in Yahoo, and presently Yahoo has more than 4,000 plus nodes in the cluster, in single cluster, which are running, and Yahoo is giving full support for Hadoop framework. And there are other vendors which are also working over this, like here if I'll say like Cloudera as one of the biggest vendor who is providing support on the Hadoop framework. Second is Hortonworks. They are also introducing technologies or implementing technologies above Hadoop framework. Okay, so this is all about Hadoop core technology. Okay, so let's start with first introduction to HDFS. This is distributed file system. What distributed file system? So suppose you have 1000 nodes of cluster. That's flat, put it flat. This each box represents one node in the cluster. So you have 5 node cluster over here. It's bigger than that, but your HDFS is underlying framework right over this. So HDFS is file system, which is every machine has independently, and this file system can easily communicate with each other. Communication is possible among this machine's file system. So as soon as you want to store one file, suppose this is your file and this is let's say 100 gigabytes size, and your one machine capacity is let's say 20 gigabytes. Okay, each machine can store. Okay. So now your 100 gigabyte file want to store over this machine. Is it possible on single machine? No. So what you just give this file to the HDFS break this file into, suppose let's be little flat this division on this 5 blocks, not 5 part. Don't say this is misnomer. Block is something else, terminology is 5 part, and each part is stored in like 20 gigs or stored over here, 20 gigs stored over here, 20 gigs, 20 gigs, 20 gigs. So this HDFS will divide, and this is the responsibility of HDFS to dividing this whole file into multiple part and storing into the, and whenever you want to read it again this file, so HDFS will combine this whole file and give you back. So this is whole responsibility of HDFS. How this work in HDFS framework and kind of thing will see in later sessions actually. So this is all about HDFS file system. This is the main functionality of HDFS, which can connect it with multiple machines. So now let's take the MapReduce framework. This is programming framework. Map and reduce. So as name suggests, you can divide this into two. One is map, another is reduce. So whenever you write some programming or to solve your problem, you have to write one map function and one reduce. It's not necessarily only one map function. You could have multiple map function and multiple reduce function. So let's say, to example, as an illustration, you have this file, you want to process it. Okay, this has multiple lines and this file is quite big, and so you have written one map function. Okay, so this file input will goes to this map functions, and map function will produce out of this key value. As name suggests, it's a map, key and value, okay, for whole file. And what would be the key and value? It's decided by your program, but let's say simplicity here, this key would be your line number and value would be the actual line of this. And once this map has produced our output, so of this whole goes to the input to the reducer, some reducer framework. And this is actually all. We'll see in detail how key and value is processed and how in between many steps is for sorting, shuffling or managing, but this goes to input as input of this, and it can generate some output which is reduced. The name suggests it could reduce your whole data, or it doesn't mean actually is to reduce. It depends on what algorithm you have written or what code you have written inside this. So it generates some output. So this is all, and it could be like, again, this output could be key value again or something. So we'll take an example of word count in later session and see how exactly this. Yeah, so let's just assume here there's like map generate key value, and this key value will go to the reducer, and reducer will generate your output, and this is your actual desirable output from this file. So it's simply, if we'll say, like, you extract the data, you process it in mapper and reducer and generate your output, and this output is stored in your HDFS file system. From here you can move it anywhere, like in your RDBMS system or your NoSQL system. We'll see what is NoSQL system or something, or you just keep it in file system or something. So this way its output is being generated. Okay, so this is all about introduction to the Hadoop code, and let me draw one diagram which, like, the all new technologies that keep coming over the Hadoop framework and how it looks like and how it based on. So the base of this Hadoop framework is, say, this is the HDFS. This is the file system, and over this there is a MapReduce framework. MapReduce framework, and over this there's Yahoo has written one framework, that is Big, which can eat everything, as they say, or Facebook has written another framework, that is Hive. And this both has different purposes. This is data flow language generally, and this is data warehousing solution. You can create tables or kind of thing, but it both uses MapReduce framework to process your data. And over the HDFS there is another framework, for Design, NoSQL. This is example is HBase. So this is kind of your database which can store, but not exactly RDBMS. This is NoSQL database. Okay, so don't confuse with the RDBMS. Okay. And for full cluster coordination there is another framework, this is Zookeeper. And above this, some to extract data from the HDFS, here it has written some scope framework which reads data from your and can give you store in RDBMS, or it can read data from RDBS and store in, so it is bidirectional. And there is a Flume, another framework which actually directly connected with your already running cluster servers, which are like social networking web servers or app server. From there it reads log files and process it, kind of thing. So continuous processing is possible using Flume. And all about this you can generate your analytics reports, etc., and recommendation in them. So we'll see, like, there are various applications you can write it. So this guy can see your report, this guy can do some analytics, this guy can do some recommendation engines, like these are all. So this is all, I'll say, is a Hadoop ecosystem. We'll see in later session about each and every project. Okay, so for today this we are finishing over here. This is, so let me conclude over here, like today we have finished the introduction to big data and introduction to Hadoop, and how Hadoop can be used to solve big data challenges in today's environment. So in next session we will go in more depth about the Hadoop framework, and we'll see how HDFS works and how MapReduce framework works. So thanks for listening. We'll see and meet in next session.